In this video, we push further the idea of equations generating fresh and novel functions and introduce some new notation for functions. Last time, we saw that we could think of the equation xy equals 1 as a function in two different ways. First, we thought of it as a function that we input a real number and output a real number. We write this like this. What we mean here is to say that f receives a real number and outputs a real number. I should also exclude the number 0 from this allowable set of inputs. In particular, if we feed f the number 0, I don't get any output at all. But roughly speaking, this framing of this function is a function that receives real number inputs and gives real number outputs. On the other hand, our second interpretation of g was quite different. This was our Boolean interpretation. The input of g was an ordered pair, and the output of g was either a t or an f for true or false. To give an example of each of these, here I could write that f of 4 equals 1/4, and for g I could write that g of 2, 3 equals f. So here we'll push things a little bit further. In particular, we'll look at the following equation. Now, this equation is quite a bit more complicated than the one we looked at last time. In particular, it has 3 variables instead of 2. So how can we frame this as a function? Well, for one thing, if I specify x and y, z will be really easy to identify. So I can write this as a function in the sense where I input x and y, and we output z. In particular, I could write, for example, if I input the ordered pair that xy equals, say, 0, 2, then I find that z must equal -1. So here's our first framing of this equation as a function. Its input is some element of R2, some ordered pair, and its output is some real number. Alternatively, we could frame this as some sort of Boolean function. If we want to get a true-false output, we would want to input an entire ordered triplet. For example, if I input, say, 1, 1, -1, I find that this equation does actually turn out to be valid. So I say that g of 1, 1, -1 is true. Now, I have a third interesting interpretation of this equation as a function. If I input a, say, z value, I get an equation in terms of x and y. In other words, if I input some z value, I actually get some line in the plane. If I input a z value of 0, I get the line x plus y equals 1. If I input a z value of 1, I get the line x plus y plus 1 equals 1. So for any input of z, I get some output of a line. So we've seen that an equation can be used to generate functions in quite a variety of ways. And I'd encourage you to try to remain as flexible as possible in your understanding of what functions are and what sorts of functions we allow ourselves to create and to consider.